Hello and welcome. My name is Heather Gonzago and I'm joined by my colleagues Jonathan Uline and David Kerner, and we're here to discuss 2D and 3D web editing using the JavaScript API. Before we even get started, I just wanted to mention that all of the slides and the demos that we discuss in the presentation today are accessible via my GitHub repository. Here is a short URL to this repository. Also, if you just do like a basic search for Heather Gonzago in GitHub, you'll also find this in addition to previous years' demos and presentations. So, go. All right, so let's go ahead and get started. Over the course of this presentation, we're going to be discussing various parts as to what actually goes into web editing, specifically with the JavaScript API. We will be discussing both the 2D and the 3D parts to it, and we're going to show both the easy to use, the already provided widgets like the editor widget that allows you to perform basic editing. But we'll also go in and discuss some custom workflows with some more specific use cases as well. So when we discuss editing, we first need to discuss the very basic fundamental concept that data needs to be stored within an editable feature service. The data can be either in one or multiple feature layers within a feature service, and it also must be enabled to allow editing. So if we click on this, this is just a link here that takes you to our ArcGIS REST API doc, the documentation. And this is just the overlying or the overview doc for the feature service itself. It shows you the URL, the operations that you can work off of it, a description, and so forth. So it is possible to set additional constraints to the client, but the thing to remember is that the constraints to what you can actually do with editing is going to be set directly at the server level. So it is possible to set additional ones on the client using our API, but the one thing that you're going to need to remember ultimately is that I don't know, let's just say you have data that's, I don't know, for example, set to be only read-only at the service level. So when you created it, the feature service itself does not have editing privileges set to it. There is going to be no way for you to override that directly within the client in a web application using something like the JavaScript API. And this is going to be true for all clients, regardless of what it is that you're going to be working with. These constraints will depend specifically with how that service is set up. So there are ways to configure how you wish to constrain editing within your feature service. Here's just one example. It's just basically all this is just a screenshot showing the settings page of if you have a feature service or a feature layer, a hosted feature layer in ArcGIS Online. This feature service has been enabled to allow editing. In this right here, we've got it enabled editing. And in this particular case, we're basically telling it that, like your end user, you're telling it in this case, we're allowing it to do everything. We're telling it that they can add, they can update, and they can delete features. If you don't want this though, you can lock this down further, and you can specify the exact operations that you are allowed and what you do not want to be allowed. In addition to this, you can also restrict what editors are able to actually see within the data and what features they are allowed to actually edit. So that's what we have set right down here. All right, so we know that we need to have an editable, is that even a word? An editable edible feature layer from a feature service. And with this underlying service, we can edit this in various ways. Under the hood, all the editing is going to be handled using the REST API. So before I just showed you that feature service. So under the hood, everything is handled directly here when using the REST API. The feature service does have multiple operations that do allow editing, and the API, our APIs make use of these calls within our classes and the methods. So in addition to this, we also have ArcGIS Online. And you can do this, you can do your edits in something like ArcGIS Online, or if you have your own portal instance installed of the map viewer. And this basically allows just a nice GUI, just a nice UI experience for editing that under the hood is still using those same REST API calls for the feature service. All right, so lastly, we do have other options, like using one of our APIs, like whether it is you're working with Python or, in our specific case, working with the JavaScript API. All right, so with all of that being said, let's just talk a little bit about working with the JavaScript API specifically for editing. So we have a couple of options. The first, we have already provided configurable widgets that handle, it basically handles a lot of the complexities of editing for you. So really all you need to do is you just add the widget, specify a feature layer that you have editing privileges to, and you add this widget to your application, and it will work. The functionality for the editing is going to be already baked into that widget for you, so you don't have to write a lot of additional code to handle it. That may not be exactly what you need. You might have more of a customized workflow, and if that's the case, we do provide a more granularized approach as well with working within our APIs. So first, though, let's focus on the configurable widgets portion. So we talk about this editor widget, and basically, this is just the API reference for it. So the editor widget itself, and I'll show you in just a moment here with a demo showing you how to use it, but the editor widget itself has multiple components that are pretty much baked into it that they each have their own specific functionality. So the editor widget is comprised of the sketch component, which pretty much handles all of your geometry manipulations. So any type of additions or updates or deletions, that's going to be handled specifically within the sketch widget, which is, again, baked into that editor widget. And then secondly, we have the feature form. And the feature form, that is going to handle all of the attribute level editing. So take a look here, and we have an API reference specific for the feature form. And then lastly, within the editor, we have our feature templates. And basically all that is all this does is it just displays the templates that you have set within that feature layer that makes it basically makes editing easier to manage. So in this particular case, these would be our feature templates: graffiti, manhole cover, and so forth. All right, so next we have the granular APIs. And these are specific APIs that can be used in situations where maybe a more customized approach might be necessary. I'm not going to go into too much detail on these individually, since Jonathan and David have some really good information and demos to share specific to it. But as a basic overview, though, we do have the sketch view model. And this is going to be the underlying API that handles, I showed you the sketch widget. That sketch view model is that underlying API that handles the core logic and the functionality for how that sketch widget works. So you can access, we expose the properties and methods to you off of the view model as well. All right. In addition to the sketch view model, the graphics layer is where pretty much all of your features are going to be stored and manipulated. So working with the sketch view model, you're going to also have that graphics layer. The feature layer apply edits. Remember when I mentioned that the REST API calls and everything under the hood is working with these REST API calls? You can still perform editing directly on the feature layer. You don't even need to use the editor. You can use, before we had an editor widget, which came out with version 4.11. Before this, if you wanted to perform any type of editing, you could still do that. Using our feature layer, the actual feature layer class, we have an apply edits method off of that. And this apply edits is going to be taking basically the same type of arguments that you are provided to you if you did the same call using the REST API. And then lastly, you can still make use of the geometry engine. And this will allow certain functionalities like if you're buffering or maybe cutting or even doing things like unioning. And we have the geometry engine here. So as you can see here, all of these classes are provided to you directly within our JavaScript API. A lot of it really is going to be dependent upon what it is in your specific workflow and your use case and what you need to do with your editing. All right, so all of that said, and a very, very brief high-level overview, let's take a quick look at how this editor widget works. So remember I went in and showed you the API reference for this. And at a very high level, what we have here is, this is the editor widget. And this is just a sample. I bring it up. You can access this directly within our API reference. If you click on editor and then just scroll on down, you can read through it. And we have some samples here that work with it. This is just the very basic one using the editor widget. And all I'm doing here is I'm passing in a web map that has one layer. In this case, this layer is this hazards, and it is set as an editable feature layer. And then all I'm doing is I'm creating a new instance of this editor, passing in the view that I'm working with, which view I want it to be associated with, and then I'm adding it, and that is it. By default, how the editor works is it's going to grab whatever layers that you have added within your map, and if they are configured to allow editing, it will bring them in. You can modify these and make it more customizable to your specific use case. In this case, we're just letting it go to all of the defaults. So if I want to go in and the default editor, this is how it shows. If I want to edit a feature, so I want to go in and say, hey, this was incorrect. This is actually, the hazard type should not be road not, or actually, I'm sorry, let's keep it as road not passable. Let's just say, hey, we've fixed this already, so we can close this out. So I can go on in here, update this, and if I go back in, let's just try, we're gonna add a feature as well. Let's just add, and this is taking what you can see here. These are all of the feature templates that I have associated with this layer. So I'm going to put in, I don't know, we've got some flooding, let's say, over here next to the river. We're going to go ahead and add that, and then add that new feature into this feature layer. And I'm going to show you something very quickly here. I'm going to open up my Developer Tools console. And what I wanted to show was remember what I was mentioning before, under the hood is just making these calls. It's actually making an apply edits call onto that feature layer. If we go back in here and let's add another feature. And we'll just put one in there. If we go in, what we should see here is, yes, we have this apply edits that gets called. If I open this up in a new tab, okay, yeah, if I open this up in a new tab and then took the information that I passed through, so all of that header information that I passed through here, these ads and so forth, it basically what's happening is it's taking this and under the hood, it's calling this apply edits. So as I mentioned prior to that, the editor widget, that was a very, very basic use case out of the, I wouldn't say out of the box since it's not it's a straight widget. But you can go in here as well and configure this with some additional functionality. If you want to customize it a little bit, there are ways of doing that. We have additional properties. You can specify which layers it is that you want to have set, and you can even restrict the editing constraints on it even a little bit more as well, using the properties set within the widget. This is all I'm going to discuss on the editor itself on a 2D aspect. I'm going to let David show you in a later demo. He'll show you how it actually works with 3-dimensional features as well. So with all of that being said, I am going to pass this along here, and I'm going to let Jonathan take it over with discussing doing more custom workflows with 2D editing.
Thank you, Heather. Hey guys, my name is Jonathan Uline, and I'm a developer on the JavaScript API team. As Heather mentioned, I'll be discussing custom workflows for editing with an emphasis on 2D. This includes showing some demos and going over the underlying logic. To give a quick recap, the editor widget is comprised of several other specialized widgets. This includes the feature form widget, which is a form-based attribute editing component, and the sketch widget, which is an interactive geometry-based editing component. The demos we'll be looking at focus on app-level customizations for these components. I should note that because the editor typically manages applying edits back to the layer, using these components on their own will require you to apply your edits at the app level. Don't worry, Heather discussed how to do this earlier, and we'll see another example of this in one of the upcoming demos. Alright, so first we'll be looking at the feature form widget. As mentioned previously, the feature form widget provides an extremely flexible form-based attribute editing experience. To kick things off, the feature form requires developers to provide a feature. With this feature, the widget looks up metadata from the feature's associated layer. From there, the form is generated based on field metadata, including the field's type. The field's type dictates what kind of HTML input is displayed for that particular field in the form. For example, if the field is a domain or type, we'll show a drop-down list with potential values for that field. If the field is a date, we'll show date and time-based inputs separately. This behavior is configurable through various widget properties, which we will look at in further detail in our first demo. Okay, so let's look at our first demo. We'll be looking at the demo in action first before diving into the code. This demo uses a dataset representing coyote encounters in Oakville, Ontario. When the demo first loads, it picks a random feature from our layer and displays the feature form. From here, we can update our attributes and submit the changes with the Update button. Alternatively, we can select a new feature for our feature form by simply clicking it. In this particular sample, we requery the service for the latest version of this feature to prevent displaying stale data. Let's go ahead and update the attribute. I'm going to open up Chrome DevTools and use the Network tab to ensure our update was, in fact, successful. So here we're going to change Old Spooky Woods to Dev Summit 2020 and hit Update. Great. So we can see our apply edits was successfully called and the update was approved. So now our feature is updated on our feature layer. So let's go ahead and look at the sample and what's kind of going on under the hood here. As a quick reminder, all of these samples are available on GitHub. So let's dig into this sample. Let's scroll down and look at our HTML first. As you can see, all we're doing is simply creating a div for our view, and we're creating a div container for our widget. We have the feature form itself, and we have the update button. So let's look at the JavaScript logic here. We're importing our modules. We're getting some references here. We're setting up some app state management variables related to highlighting, which is that blue kind of glow around the feature that is selected, and then a reference to the currently selected feature itself. We're going to set up our layer, our map in our view. We're going to add the layer to the map, pass the map to the view. We're going to disable pop-ups on the view for this particular sample. And we're going to create a click event listener on the view. In the click event listener callback, we're going to unselect any currently selected features and hide the form. We're going to run a hit test on the view and provide the click event, which will tell us if there were any associated features where we clicked. If there is in fact a feature where we clicked, we get the object ID of the feature and pass it to our select feature method. In the select feature method, we are querying the feature layer for a latest version of our feature to prevent having the stale attributes on the client. When we get our feature, we're saving it to our app management variable. We're passing that feature to the form, and we're highlighting the feature. We're also displaying the form's container. Scrolling down a bit further, you see two additional methods. This is for removing the highlight of selected features, and this method is the one that selects a random feature when the layer loads using the view's extent. So when the app loads, we grab a random feature from our query and pass it to our feature form selection method. Further down the line, we have the logic for configuring the feature form. Here, you can see we have a field configs object. This acts as a whitelist for displaying fields within the feature form itself. That is, if you provide a field config object, any fields you want visible must also be provided. So here you can see that we're configuring and customizing some of our labels for our fields. Further down, we are listening to the form's submit event. We're checking if we have a feature to edit. If we do, we are getting the updated values from the form, setting the attributes on our selected feature, and passing the updated feature to our apply attribute updates method. From here, we use feature layer.apply edits. We provide the updated feature, and from here on out, if our update was successful, we reselect the feature in the feature form, which will then again fetch a brand new feature with updated attributes. If we have any failures, we print a console error for you to easily digest. So what can we do to customize the feature form to make it a little bit more robust? Well, let's start with our field config object. Sorry, I misspoke. The field config property. The field config property is actually an array of objects, with each object representing a field or attribute for the associated feature. It's important to note that field config is a whitelist. So let's take a look at what we can do with field config. We're going to go ahead and go into this little cheat sheet I have to save some time so I don't have to type all this out. You can just trust me on this. We're going to go ahead and replace what we have now. So what we're doing here is we're actually creating a custom domain for the encounter field. What that means is we're changing a simple string field to a coded value domain. which will then display a dropdown instead in our feature form. Our potential values in our dropdown are provided via the coded values array. In this case, it'll be encounter, citing, garbage, and feeding. So I've gone ahead and saved this. I'd also like to note that encounter is now ahead of location, and the order that you define your fields, your field configs, will determine the order that they are displayed in the feature form. So if we go ahead and go back to our demo and we refresh, we should take note that the fields have changed order and that the encounter field is now a dropdown with our 4 values. Great. So what that allows us to do is kind of enforce some specific types on the client, which may not be enforced on the server side. So if we go back in here, let's look at something else we can configure with field config. Let's look at grouping. Grouping is really convenient for displaying like attributes together. So here again, we're kind of building off the previous example where we have a custom domain. But now we also have this kind of grouping where we're going to group general information attributes together, and we're going to lump attributes related to status together. So I've saved my sample. We're going to go ahead and refresh. And what we should see now are indicative of grouped fields. So we can see that this group is disabled based on our field config, and they're grouped together with a title and some descriptive information. Now, let's go back and look at one more customization with our field config object. This is newer and actually incredibly powerful. It's an example of conditional field display. So here we're going to copy and paste our field config, and we're going to dump that in there, and we're going to save. So again, similarly, we're building off of our last customization example with our custom domain, our custom groups. Additionally, now the location field has been modified to only display if the encounter field is equal to garbage. So now, if we go ahead and refresh our feature form, we can see that the location field is no longer displayed until we select the garbage value for this particular field, which then displays the location field. This allows you to build really complex and dynamic forms, really specific to the app's need. I think there's a lot of power there. With that said, this was just a brief demonstration of the powerful capabilities of the feature form widget. So from here, we're going to jump back into our slides, and from here on out, I'll be talking about the sketch widget and geometry-based editing in the 2D context. In the image on your screen, you can see an example of the sketch widget in action. As a reminder, the sketch widget is used to modify feature geometries. It provides 2 major workflows or operations out of the box: create and update. Delete has been rolled into update. The sketch widget provides configurable options for both workflows. And the sketch widget manages user interactions with the view internally. What this means is there's not very much setup required in your app to get the sketch widget up and running. This can be disabled to provide more control directly to developers. What this really means is you would be able to set up a hit test in your app. You can filter out invalid candidates for the update workflow. You can run some validation there, and basically have total control over what type of graphics are passed to the sketch widget. With that said, let's jump into some demos. So the first I just want to kind of point out, it's our Hello World sketch sample in the JS API documentation. I'm not going to spend much time on it. I just want to kind of showcase What the sketch widget does, in case you weren't familiar, you can create a feature. I just created a new polygon. You can also update them. This includes scaling, rotation, movement, and simple vertex manipulation, including adding and removing vertices, in addition to deletion. So that's the sketch widget in a nutshell. So let's go back and take a look at some of these demos. The next demo we're going to be looking at is using apply edits with Sketch View Model. I haven't talked about Sketch View Model yet, but if you recall, Heather kind of described view models as the brains of the widget. They contain most of the logic. On the flip side, the view of the widget contains most of the UI UX rendering logic there. In this case, we're using Sketch View Model for simplicity of the sample, but it also applies to the Sketch widget very similarly since they share events. So you could easily replace the Sketch View Model with the Sketch widget here in this sample. Really quick, there's not much to it. We have a single button which activates the Sketch tool, and I can draw a polygon. My polygon finishes, it disappears, and reappears in place. I can also Shift-Control-Click to delete a polygon from our sample. So let's actually take a look at what's going on under the hood here. We'll start with the HTML again. And again, these demos are available on GitHub. So very similarly to our other sample, we have to set up a view div. We're setting up a container for our sketch button and the button itself. So if we go back up, we require our needed modules. We'll set up our layer. In this case, it's a polygon layer. We're creating a new graphics layer because Sketch View Model works off graphics layer. The Sketch widget kind of handles this internally as well. So it's just another step if you want the flexibility of Sketch View Model. You're going to create your graphics layer, you create your map, you create your view. And when the view is loaded, we're going to set up our Sketch View Model. We're going to pass it our graphics layer, and we're going to pass it the view. We're going to set up a create event listener on the Sketch widget, the Sketch View Model, sorry. What it's going to do is check when we have finished a create operation. It's going to remove the graphic that we just created from our graphics layer, which is automatically added by the Sketch View Model. And we're going to call apply edits on our polygon layer with our updated graphic. We're going to add it with add features. Further down, you can see the click event listener for our polygon button to actually start a create operation. And we have our view click event listener here for deletion. So unclick, if I have Control and Shift selected, we're going to run a hit test using the event. And we're going to basically get a response that tells us if there was any graphic where we clicked on the view. If there is, we're going to go ahead and delete them from our polygon layer using apply edits. So pretty straightforward, right? It's driven by this eventing system. We just kind of need to know when we've finished creating something. The same goes for update. It would be very similar. You just replace create with update here in the event listener. And that's all you really need to go from client-side editing to server-side editing, a combination of both. So that's a pretty quick sample. We're going to go back. And the last sample we'll be looking at is creating custom tools using the Sketch View Model. All right, I'm going to go ahead and open up this sample. Let's take a look at what we have. A pretty plain sample. We have 5 buttons in the top right corner. 3 of them represent different polygon-oriented drawing operations available via Sketch View Model. We have our freeform polygon, we have our rectangle or square tool, and we have our circle tool. What are the 2 other buttons? We have cut geometries and union geometries. I'm going to have to ask you to use your imagination. The cut tool would probably typically have scissors as an icon, but for this demo, we're making do. So I've activated my cut tool. As you can see, there's now a polyline on the app, and I'm going to go ahead and click and finish and essentially cut these different polygons into separate pieces. So what we can do here is use the second tool, union geometries, which then uses the rectangle tool to select and combine any features contained within the extent of that rectangle. So cool. These are just, custom tools using the geometry engine. So let's take a look under the hood at what's going on. Back in our code, let's scroll down and take a look at what's going on. We'll start with HTML first. I set up a div for our view, which contains a draw container, which contains two button containers, which each contain a variety of buttons. I've grouped our polygon creation buttons together, and I've grouped our custom operation buttons together. So let's look at some JavaScript. Scrolling back up. Similar to the previous sample, we create a new graphics layer, a new map, a view, and we're going to set up a app-level variable called active custom operation, which will store whether or not an active cut or union operation is going on. Next, we add our draw container to the top right of the view UI, and we're going to set up a listener for when the view is finally loaded. We then create our sketch view model, and we wire up our buttons. When you click a button, all it's doing is creating an associated operation via sketch view model. In cut and union's case, we're storing the fact that it's a custom operation at the app level, so we can reference this later. In fact, here. We're going to set up an event handler for sketch view model's create operation. We only care about when the create operation is successful or complete, so we check the state property on the event. If an active custom operation was used, like cut or union, we're going to pass our associated graphic to one of these callbacks. So let's take a look at cut first. On cut operation complete, what happens? Well, we pass a cutter graphic. We remove that graphic from the view because we're not necessarily concerned with displaying the cut graphic after we've kind of drawn it. We're going to shallow clone our layer graphics to preserve them while we're doing geometry manipulation. And we're going to loop through them and use Geometry Engine's cut method, which requires passing a geometry to cut and a cutter geometry, which is a polyline. It returns an array of potential cut geometries, since one line can cut a polygon into multiple segments if you use a multi-segmented polyline. If we have valid cut geometries found or generated by the geometry engine, we're going to loop through our geometries and create new graphics from the geometries. We will also reuse the symbol of the original graphic. Once we're done with that, we remove the big graphic that was cut into smaller pieces from our layer, and we add the newly cut graphics to the view. Fairly straightforward process, simply utilizing the geometry engine's cut method. So we can take a look at union now, probably pretty similar. We expect a union graphic, which in this case is a polygon when you want to do a union operation. We'll remove the union graphic polygon from our layer. We'll similarly shallow clone our layer graphics, and we're going to create a store for potential target graphics that is union candidates. We're going to then loop through our layer graphics, and we're going to use geometryengine.contains, which will tell us whether or not the provided graphic is contained within our extent graphic. We essentially want all graphics contained within the extent of our union graphic to be unioned or merged. So that's why we're using contains in this case here. So we save a reference to these valid candidates in target graphics. Then, once we're all done looping through our graphics on our layer, we look at target graphics, we see which candidates are valid, and we use these geometries with the geometry engine union method. We pass an array of geometries to the union method, and it returns a single geometry that we can then use to create a new graphic. So we make sure that the union geometry was successfully created by the geometry engine. We're going to create a new graphic here. We're going to reuse the symbol of the first target graphic. We're going to remove all of our target graphics from the view, since they are now merged into one bigger graphic, and we're going to add the bigger unioned graphic back to the view. So that about sums up this sample. I think it's fairly straightforward in its workflows. What this sample does well is highlight how powerful the geometry engine is for client-side geometry manipulation, in addition to how easy it is to use Sketch View Model or the Sketch widget to generate geometries to be used in said operations. With that said, let's go back to the slides. I wanted to briefly mention that there are additional demos that I have not shown today that will be also hosted on GitHub. One of them includes client-side snapping and on-the-fly geometry manipulation, and I highly suggest you check them out. With all of that said, I'm going to let David discuss custom workflows in 3D editing and pass it along to him. Thank you very much.
Thanks, Jonathan. So in the third part of the talk, I will be covering everything 3D related to editing. And the first and the most important message is that with version 4.15, we will fully support the editor widget in scene view and 3D. So here you see the example Jonathan showed to demonstrate editing in the map view using 2D maps. And what I did here is I took the data and applied it to a scene view. So now we have the same data, but now we get the 3D visualization. And in scene view, I can also now create an editor widget, I pass in the scene view instead of a map view, and then I add it to the UI. And then I get the editor widget. And this supports all the editing workflows you have seen from Jonathan and Heather. So I can now go in and I can basically click features. I can update the geometry. I can use the move tool, the reshape tool, the feature forms, all these things I can use, and it's exactly the same. And the important point here is that you don't need to prepare your data in any special way. It works out of the box. You just change from map view to scene view, and you get all the editing workflows. In addition to that, we now also support creation and editing of features with C values. And for this, I would like to first quickly reiterate on elevation modes, because that's an important concept in 3D. So elevation modes basically define how C values on the geometry are interpreted. And here you see a schematic view of the scene. You have the sea level, which is the sea level basically. Then you have the ground, which is this brown line here, and that's specified, or that's given by the elevation of your elevation layers in the ground. And then we have, for example, extruded polygon symbols in the scene, or a scene layer or something like this. And this is what we refer to as scene. It's scene geometry. And now if with your feature layers, you don't have any elevation info provided, then by default, we assume absolute height elevation mode. And this means that the C values of your feature geometry is relative to sea level. So a C value of 0 will place your geometry at the sea level, and everything above or below will be an offset to that. Further, we have relative to ground elevation mode. And this you can specify, and then the C values of the geometry are given relative to the ground elevation. So a C value of 0 means that your feature geometry will be aligned with the ground. And everything above or below is again an offset to the ground elevation. Further, we have relative to scene elevation mode. And here we further take the scene geometry into account. So basically, C value of 0 means that your geometry is placed on the ground if there's no scene geometry at this XY location, or it is placed on the scene geometry if there is basically a scene layer or an extruded polygon, for example. And again, C values above or below basically are an offset to this C equals 0 surface. And finally, we have on the ground elevation mode. And this basically means that all C values are ignored and the geometry is always placed on the ground surface. And for some symbols, like for example line symbol layers, this means that the features are draped, which means they are rendered to the ground texture. So now let us look at feature creation. So here I have an empty scene. There's no feature layers, but I have already added an editor widget. And if there's no feature layers in the scene, you don't see the editor widget. So now let me first add a feature layer, but the feature layer has been set up such that there is no C values on the geometry. So the feature layer shows up as soon as I add this feature layer, and I can start adding the feature. So, and as you see, I basically am able to move the feature around. I can use the reshape tool to basically create new points and place the geometry in the scene, but I don't have a way to change the C values. And this is because the feature layer does not support C values at this point. The geometry has no C values, and this is why we can only change XY. Now let me go ahead and create a feature layer which has been set up in a way such that the geometry of the features have C values. And you have seen by Heather and by Jonathan how you have to do this. So I added the feature layer now, and the feature editor, it sees the new feature layer and allows me to now choose which feature I want to create. And I want to create the feature of the new feature layer, which has C values enabled. So I can go in and draw the feature layer. Feature. And now you see the vertical arrow, which basically allows you to change the C values because the feature has C values. It comes from a feature layer which supports C values. And this also works for reshape. So if you reshape the vertices, you can actually change the C values of individual vertices. Now let me go in and add another feature layer which uses extruded polygons. So adding this feature layer, the feature editor picks up the new feature layer and allows me to place features for that feature layer. So now let me start drawing extruded polygons. And there we go. And since the feature layer has been set up to not have C values, I don't get the vertical arrow. I just get the polygon and can move it around. Notice how drawing the new feature will, during the creation stage, just give me like a default visualization of the polygon, but not the actual extruded polygon symbol. If you want to change this, you can use the supporting widget defaults property of the editor. And this allows you to define some properties of the different subcomponents the editor uses. So the editor uses the feature form and also the sketch view models. And here we can basically specify some properties for the sketch view model the editor uses internally. And in more detail, we actually specify the polygon symbol, which is the symbol which the sketch view model will use to create the feature. So after I run this code, I can now go in and start creating the feature. And as soon as we have 3 vertices, you can actually see the polygon symbol showing up. And what's really nice is that you can basically modify the geometry while still seeing the symbol applied to the geometry in place. So now let me change the elevation mode of the feature layer, which doesn't have C values. So in particular, this feature layer I used to draw this line feature here at the beginning, and I will change the elevation mode to relative to scene. And this means that the feature now is basically the height of that feature is defined by the scene elevation. And so extruded polygons are considered part of the scene, and therefore this feature layer will align. And I can further, to make it more visible, apply a path symbol to this line. So I clone the renderer of this feature layer, I assign the path symbol, and then I assign the cloned renderer to the feature layer. And this gives me the path symbol. And I can now go in and still update all the features, and these updates will be propagated correctly. So I can move all these things around, and you see the geometry being aligned correctly. So this concludes feature creation. Let us turn towards updating. So updating is very simple. Here's a feature layer which has a point feature, and the point feature is assigned a object symbol 3D layer. And if I update this feature, I will get the transform manipulator, and that has the vertical arrow, which allows me to change the C values. And here also the supporting widget defaults allows us to specify some default options. And what the sketching model now has, it has this option to basically enable C and to turn that false. So the update options, if you specify enable C or false, this means that the sketching model will not allow updating the C values of your feature. So if I run this and then I edit my features, you see there's no vertical arrow anymore. And this is because we have turned C editing off, basically. So this is useful if you have some data and you don't want the C values to change, or you don't want these vertical arrows to show up for the users, then you can turn C value editing off. So now some note has to be said about data with visual variables. Visual variables are very useful. And here we have an array of cubes, and what we do is we now apply a visual variable to these cubes. So we just specify the visual variables with the renderer, and here it's a size visual variable. So the size is now driven by an attribute of each feature, and this attribute is called size, and it is just specifying the size in meters. And what's important is that now you still can use the editor widget, and you can use the manipulator to update this value. So here you see the scaling of the manipulator, and this will actually apply the scaling to the attribute driving the visual variable. And the same is true for rotation. So here I apply a rotation visual variable, and I can select the feature, and then I get this rotation handle, and this allows me to change the attribute driving the rotation. Now, if you want to turn this off, this functionality, so that you are not able to basically update size or rotation, you can also use some default update options. And in particular, you can use enable rotation and enable scaling to explicitly allow or disallow rotation or scaling of your features. So if I run this code and I update the feature again, I don't get the rotation handle or the scaling handle. Finally, now some more advanced example. So here I see that you may want to have an application where you have some features on a feature layer. Like in this case, we have one feature layer, and this has this line feature. And in your client application, sometimes you want to have additional visualizations. So for example, here we may just want to visualize just on the client side the start and the end point to basically identify where the feature starts and where it's ends. So I have written a function which is doing this. So it takes the feature and it places a start and an end label. So let me do this. And these are stored in its own graphics layer, just on the client side. So there's no feature layer and there's no feature service. This is just client-side visualizations, basically. And now a problem which is occurring is that once you update the geometry, you see that your client-side features are not synchronized with the feature layers. And to circumvent this, we suggest to use a callback on the feature layer. So the feature layer allows you to listen for this edits events. And this edits event will be emitted once the user updates a feature or creates a feature or deletes a feature. So this is a nice way to get notified when the user has updated a feature using the editor widget. And what we do here is we iterate over all updated features, and from the feature, each feature basically has its object ID. So the features are identified with the object ID, and we can use the object ID to invoke this function called synchronize client graphics. And this will be in charge of making sure that the client-side graphics, like the start and the end label, are kept in sync with the actual feature. So this function is defined up here, and it uses the query feature of the feature layer. So it gets the object ID, and then it creates a feature layer query object, And here this is important. If your features have C values, you have to enable return C. And you have to set it to true, otherwise you do not get C values of your geometry. And further, we can actually specify the list of object IDs we want to query. So here we just pass this one object ID of this one feature we want to update. And if this is not specified, you will receive all the features of the layer. So, and then we basically run the query. And this is an asynchronous function. And once the promise resolves, you get a callback with a feature set of all the queried features. And then we use this function here, which basically takes the feature and it basically uses a geometry to find the start and the end point of the geometry, and then it looks up the client graphics and synchronizes the client graphics correctly. Okay, let us basically run this code. So we basically add the callback to the edits event, and we will see what happens. So now, if I update the feature, you will see that the client-side graphics are synchronized correctly. Now, what's still missing is that if you want to have your application in a way that you already see your client-side graphics synchronized during updating, so this is basically the user basically still updating the feature, and this is basically committing the update. And if you want to have this also be synchronized, then you have to look at the sketch view model. So I said that the editor, it uses the sketch view model to basically allow these geometry updates. And what you can do is this, you can watch on sketch view model events. And in particular, the sketch view model has an update event, and that is called whenever the geometry is updated. So what we do here is we take the editor, take the view model of the editor, then we take the sketch view model, and then we listen to update events. And if the state is active, which means the updating is still going on, then we get the graphics, and we know it's just one graphic at this point. So we pass this one graphic to this function, which I also used over here. And this takes the geometry of the graphic and synchronizes the client-side graphics. So if I run this, and now if I move the point or the geometry, then you see that the client-side graphics are synchronized nicely. So this is like an advanced example which allows you to build rich client-side applications. And so let me turn your attention to this example. This is a demo we wrote to really inspire you and show you how far you can take 3D editing in the new API version. So this is a scene layer, and we have a feature layer, and the feature layer contains these polyline features you see here in black. And once the feature layer is loaded, all these features are basically red and exposed to this custom UI. And what we do is we have a camera in the scene, and then we create animation curves from these polyline features of our feature layer. These are here in red, and clicking the button will basically align the camera with this animation curve. And this allows us to define camera animations. And the idea here is to basically have a city, maybe as part of a touristic application or maybe urban planning application, where you want to have nice visualizations or animations for certain parts of your city. And this is the use case which inspired this demo app. So further, we use editing to allow the user to manipulate positions of the camera. So the camera is a point symbol, which is just a client-side graphic. So it's living in its graphics layer. And then if you click it, then we use the view to basically give us a hit test and identify the graphic. And if it's a camera, then we use the sketch view model alone to basically allow the user to place the camera. And we have linked the geometry of the camera point to a callback, which updates another scene view, which we have here as part of its own HTML div element. So whenever the geometry of the camera position changes, we can basically use the camera to update the scene view, which is driving this picture here. And the same is true for the target point. And here we also disabled rotation and scaling. So now when I click here, what we will do is we will attach the camera to the feature which is basically associated with this feature item up here. So this is now the church feature, and now the camera is attached, and I have this slider here which allows me to basically define at which position of the camera animation I want to look at. And here we have another feature. For example, here the bridge. Or the tower. This is the tower feature. And I think the camera starts here. Yeah, it does. The target is at the tower. And then I can basically see how the camera moves. And since the black polylines are the features of the feature layers. And then we use the client-side graphics, which I have demonstrated in the previous slide, to basically generate a curve from these polylines. And these are just living on the client side. So the only thing which is residing in the feature service are these black polylines here, which basically outline the camera animation path. And what I can do is I can use the editor widget to go in and edit our animation curves. So here I use the reshape tool to basically move the points around of my camera animation curve. And I use the technique I've shown in the previous slide to synchronize the curve with the polyline geometry. So you will find this code on GitHub, and it really shows that with the new version of the ArcGIS JS API, you can do really powerful, rich editing applications in 3D. So this concludes the section. Thank you very much for checking this out. Goodbye.